So let's get it started. Today I would like to talk about generators, executors, and plugins on top of the NX Devkit. But before we start, who am I? My name is Juri Strumpflohner. I'm a Google developer expert in web technologies. I'm also an instructor at Egghead and Cypress ambassador. I work at Narwhal as a JavaScript architect and engineering manager, and I'm also part of the NX core team there. And so today I would really focus on speed, quality, and how we can achieve that via automation. And in particular, what I would like to show you a bit is like how you can take NX existing capabilities and enhance them or tailor them down to your own needs within your NX workspace. And so if you talk about workspace automation, like the kind of fundamentals, what I have in mind is three different things, right? We have like the executors, the generators, and the plugins. And all of them are on top of the new Narwhal Devkit, which I can guarantee you, like that made things a lot simpler in terms of creating those. But we will explore that in a bit. So let's start with the NX generator. So what is an NX generator? An NX generator is something that operates on the NX workspace files. So you can kind of create new files, modify existing ones, delete existing ones, but you can also just create entire projects, right? And their according configuration files. So that's actually what happens if you set up a new NX workspace or if you generate a new library, right? That's exactly a generator happening there and running there. So if you look at the types of NX generators, what we have there is like we have the core plugin generators that come already installed with like Narwhal React, Narwhal Next, Narwhal Angular, like those are built in. And similarly also the migration generators. Those are responsible for whenever you invoke NX migrate, like they bring the code from one version to the next, make sure that you have a smooth experience like whenever you upgrade. And finally, we have the workspace generators, and they are probably the ones we are most interested today in because like they help us automate our local workspace. So how is the flow when a generator gets invoked? So usually what happens is like we have the workspace, so with all its files at our disposal, and that gets kind of abstracted into such a virtual file system, that tree object. And that tree object is really useful because like all our operations go against that tree object, which allows us to simulate whether the actual operation like is successful or whether it breaks something, right? So it allows us to simulate, to perform like dry runs, but also if something goes wrong, we can roll back all the operations and we don't really like write anything to the file system, which would then be like kind of weird to undo and like kind of not really useful or handy. And then with the virtual file system, like with the virtual tree, on the other side, we have the schema, which is something you define as the author of a generator. And that is useful because like there you define the metadata, right? So what are the properties, which ones are required, what are the data types and stuff like that. And so whenever someone invokes the generator, NX already validates those inputs, like the arguments that are passed to the generator against that schema. And so you don't have to take care about all that stuff. And finally, obviously, there's the actual function which you need to implement, right? And so you will get there the tree, you will get the schema, which we just talked about, and then there's your custom logic, which you have to implement in the end. And so the logic then gets applied to the tree object, and if everything goes well, it gets applied to the native file system. So as mentioned, that tree object is really handy because like, there are a couple methods on there which you would expect, right? You can read, write to the file system, like delete something, check whether something exists, and a couple other utilities. And so all your operations are really going against that, and you'd never write directly to the file system, right? Then in terms of your logic, like how complicated you want to get there, really depends on your own like use case, right? So it could be very simple in a sense that you just take a couple existing generators and you combine them in a useful way for you. For instance, if you always want to like generate an application and a couple libraries for each new application, you could just compose like the application generator with some library generators, right? Which would be pretty easy. And then there is some more involved things, right? Where you want to modify existing files. So you could just use string replacement, like read the file, replace the string content, rewrite the file, or maybe using regular expressions to at least like target the things better. And if it gets more complex, like then you would probably want to go to ASTs. So to abstract syntax trees. All right, but let's have a quick look at a demo. So what I have here is an empty workspace. And what we want to do now is to generate a new workspace generator. So let me open up NX console. And that's the easiest way, by the way. So you just like go to workspace generator and you generate a new one. Let's call it my first generator. and let's just execute it. So whenever you run that, it will actually create the files in our file system. And so if you open up here, tools folder, generators, my first generator, you see like what got created. And here actually also generator just was executed to create this one, right? So here we have like the content. As you can see, just if you want to look briefly through this, like there's an existing generator which we pull in. We have our function with the tree object and the schema. We have the library generator which we invoke. So this generator would basically create a library using this workspace here. So nothing fancy. It invokes like a utility to format the files, which you definitely want to do whenever you change something on the file system. So this would run prettier or whatever has been set up for the NX workspace. And then we have like also the possibility to perform an install task. So if you know that we changed like the package JSON or something, we would definitely want to also run an installation like an npm install or yarn install at the end. Then there's also the schema. As mentioned, like this is the one, the metadata. So you see here we have a name properties of type string. It's like the first parameter that gets passed to the generator, and this is a required one. So if you don't provide it, this here would fail the validation. Cool. Let me have a quick look, and let's do something to get started here and like provide an actual TypeScript interface. Like this is a suggested way. Usually what you do is like you take the schema and make sure those have corresponding types in your TypeScript interface, such that then within our generator, we can actually code against that. And so for instance, we could like use a logger, which also gets exported by the Devkit, and just like invoke hello, use that options that get passed in from our schema here, the name, hello, basically attendees, right? So if you invoke this one, we can just use NX workspace generator, my first generator, and then we pass some value to it, like the name. So if I don't put anything in here, we would see the validation kick in, right? So you would see like here required property name is missing, right? So this is what we talked before. If I instead passed in nx-conf, nx-conf, we would see like the console log output here being printed out. So our generator actually was invoked properly. And there are some more handy functions here. For instance, I could go and use that names function and wrap here the property that we get in, like you pass it the value, and the names function then exposes a couple like user properties. So this is the things you usually need, like when you generate new files, right? You want to make sure that if you need a class name, you get like the proper class names or file names that they are properly escaped and don't contain any characters which are not like allowed. So for instance, a class name here would make sure to have like a Pascal case naming. And so that's what you would expect, right? So here you see like nx-conf gets converted to nx-conf in Pascal casing. So pretty straightforward, but still very, very handy. But let's do something more real world, right? So let's generate a couple of files. So what I want to do here is I want to create a files folder, and you can actually name this how you want. And I create a readme.md. And this is my file. And usually in those kind of templates, what you want is you want to basically have some templates in there, like some placeholders, right? So you basically generate the file, you pass in the data, and the placeholders get replaced with that data. Now here we use ajs.co, like that's the syntax which we use for rendering those templates. So just go to their website and you will see the syntax, the possibilities which you can have with that templating language. It is pretty powerful and still pretty simple as well. So here we defined our template. Now let's go back in here and let's actually apply this. So what we could do is kind of use that library generator, for instance, here and invoke that one with the name that comes in from our schema. So that would generate us a library, let's say an nx-conf library. And then we would want to like use our README and override existing README in that generator, right? And so the first thing after generating that library, which basically happens with this instruction here, is we would want to know where is the root of that library, right? So in order to know the path and in order to be able to then kind of replace the file there. And so we can do that via some utility functions, which is pretty handy, which is here read project configuration, always comes from Novel Devkit, where you pass in a tree, you pass in a project name, and then you get access to properties of the project, such as the root, the source root, and even other things that are handy. So once we have the root, like the folder path, basically, we can go ahead and actually generate the file. And generating the file is nothing else than invoking again a utility function. So you can see like we abstracted the most useful and most commonly used things into utility functions exposed by the Devkit. And so we give it again a tree because like that's where it operates on. We give it the path to the template files, which is basically in our directory, the files. We give it the destination path, and then there are the replacements, right? So in the template, we use conference name as a placeholder, and we would want to replace that with what comes in by the schema here. And since we write something to the file system, we definitely want to also format the files here. So let's run this. Let's again, and we can use here the dry run if you want. So we would see basically what it means like to run this like as a dry run. So you see nothing actually happens, but it just prints out on the console what would like happen here and what would get generated. And so let me actually execute this, and we should see then the final result being created. And so we get a libs folder, we get nxconf, we have our readme, and if you go in here, we see not the usual readme, but rather we see like our hi there nxconf attendees. All right, so this was a pretty simple approach of creating a generator, but it kind of gave you the idea what is needed, right? So for utility functions, definitely rely on the NX Devkit API. So you can directly go to GitHub and inspect their exported functions or the documentation, which contains like the API for the NX Devkit. If you need to get more complicated, as mentioned, have a look at ASTs. They seem scary, but there are a lot of cool tools around. So there's TS Query, which is pretty handy. And there's also AST Explorer and TS Query Playground. And finally, also check out our own generators within the NX source code, right? So we do very similar things. So it most likely something you want to do has already been done in some of those generators. You can just like have a look at those pieces and apply them in your own scenario. So the use cases for NX generators are pretty obvious. Like usually whenever you have repetitive tasks, right? So whenever you would go and kind of write down a series of steps someone would need to follow in some documentation or README, think about maybe wrapping them as a generator, right? So you just like place the actual command in the docs file rather than all the steps, and the generator would make sure that everything gets created properly. So that obviously leads to much an improved developer experience in general, but also standardization, right? So if you want to have a certain setup of your, I don't know, React or Angular components within your workspace, you can create your own component generator, right? And kind of adjust that. You can also augment existing ones. And also when you have such large-scale refactorings, like long-running refactorings, it might something be more handy to create a generator that modifies the file for you and adjusts the files for you, such that then you can repeatedly invoke those as like multiple people have still open like PRs that have not been migrated yet, right? So you can run those generators on top of that and coordinate the long-running migration. Let's go to the next step. So what is an executor then? Like we have seen now the generators, but what is an executor? An executor is basically something that performs a task, right? So it's usually like a computation on top of an NX project. So it doesn't modify the source files, but rather it takes those as an input, it does some computation on top of them and produces some kind of output, right? So if you take a look again at the flow, you type a command like nx test, nx conf, and what this will happen is it collects different kind of artifacts like the environment that it runs in, like the source files, some global configuration, and those then get passed to NX, right? And I marked it here as kind of coordinator, but there's a couple of logic, like a logic running there, which verifies, for instance, things like, is there already a cached version for that given this input? So I could just replace that with the cache, right? And so if that is happening, you wouldn't even invoke the actual executor, but rather just like create like the output in this folder or the console log output or whatever got produced by that previous run. Now, if the cache is not present, that contextual information is put ahead, like given to you as a developer of an executor. Then you also have the actual configuration of an executor that is attached to some project configuration in workspace JSON. And with that information, then you can actually build the logic itself, right? So here, for instance, you see basically the run executor function that gets the context, which has some useful information that we will need in the implementation of the executor itself, and then the options that are either configured in workspace JSON or get passed as command line arguments. Then the logic gets implemented, passed to the coordinator part, which like obviously caches the output and then obviously writes it to the output files or this directory, whatever you want to produce as a result. The use cases for such a like an executor is obviously automating computation in general. So usually whenever you have like really complex NPM scripts or like JavaScript files that you invoke from the NPM scripts, think about wrapping them in an executor, because the main benefit there is the caching, right? So since, as we have seen, this run through the NX pipeline, NX will also be able to cache it. And so you can kind of take like advantage of all those benefits. Now, for very simple scenarios, you actually might not need to write a generator itself, like an executor, sorry, but you can just like use the run commands. And I have a link here to the documentation, which is kind of an executor that wraps NPM scripts. So that might even just already be enough. But if it isn't, you can go ahead and see like how you implement a custom workspace executor. Before we actually look at the implementation, let's first also have a look at NX plugin, because we will actually use those to implement such workspace executors. So plugin is actually pretty simple, right? So a plugin is simply a collection of executors and generators, and the goal is basically to have it like easily buildable, packageable, and distributable, like shareable with others, like as a community plugin or even just within your organization, right? So it might be published to some internal private NPM registry and consumed from there. Because what sometimes happens is that you have different NX workspace where you want to use that logic. And so a plugin is basically generators, executors, potentially also those migration executors. And that's what a plugin is actually all about. And you can install and create plugins with that Novel NX plugin package. But let's have a look. Now, as I mentioned, the first step which you want to do here is actually add that Novel NX plugin. And so that will give us all the functionality to actually create a new plugin and use it here within our workspace. And so once we have that installed, we can actually invoke NX console again. And now we should have like NX plugin, and we should be able to create a new plugin. And so whenever I create custom workspace executors, I make use of those plugins just locally without actually intention of distributing them, but as we will see, use them locally. So I can call this workspace extensions, right? So because these are intended to be used just locally within our workspace. And so what we will get out of this here is basically a new library project. So this is just like as any other normal library. So you see here, we have like the executors file. You can even create generators in here. And we have also already some implementation for a potential build executor. And so if you go in here, what you will see is that famous run executor, which we have just seen before, right? And so here we can actually invoke that and already execute it. In order to do that, we need to build it. Right, so let's first build that executor. And since this is just a plugin, like a new project within our NX workspace, we can just invoke NX build workspace extensions, and that would then build it. And so what you will get is in that dist folder here, you get like that output folder, you have the actual executor in here, and so you can actually invoke that from here potentially. And so assume that what we want to do is for our NX Conf library here, we want to create something, a builder, like an executor, that is able to build a README and convert it to an actual HTML file. And so an executor is always attached to an actual project. And so we could go in here and just create a new build target where we want to attach our executor, right? And so we copy the executor in here. Now it is not anything like from @now or something, but rather from dist libs workspace extensions, and it is called build. So that is what we would invoke. Let's also give it some outputs properties. And so usually what you have here, let me just copy over this. Usually what you have here is you have the output path, and even also in here you have something like output path, which would then be like dist libs nxconf. So that will be the output path basically of that library. And so here we have now defined our executor. Now we can actually go and see whether we were able to run it. So in theory, we should be able to do something like nx build, because we are invoking that build target on top of nxconf and execute that. And in fact, what you see now is like executor ran for build, output path, whatever we specified. And that's exactly what we saw in that executor TS file, right? That's the log statement which is in there. But now let's do something more like serious. And so let me just paste in here a new basic implementation of that executor. And I'm just pasting in here a snippet that basically uses like a library, like Showdown, to take the input of the README, convert it to a markdown file, and actually then write it out as an HTML file. And so here, what we would have done, let's go through the source code a bit, is like we have those options. And first of all, we can actually go in there. This is like as our schema interface, right? So we want probably to have in here the output path, which we specified, which is of type string. And that would be what gets passed basically from the workspace configuration. Then we access the project root folder because we want to know like where our README is actually situated, like located. We want to read it in order to be able to convert it into HTML. Right, and so you can see we use that context object here to access some utilities. So the context object already has the project in there. So it's basically just like a kind of map. We give it a project name, and then we are able to actually locate things like the root folder here and other things that are useful for working with those projects. Once we have that, we just like use Node APIs. So we read in the content. We use the library, the external one, to actually make a markdown, like an HTML file out of it. Then we basically kind of determine like where is the output directory where we want to kind of place that file, and we see like that's coming from those options output paths, which is exactly like what we specified here. And once we have that, we just do some operations like in the sense of making sure the directory is created, and then we write the file, right? And then we return success true whenever this is basically like returned success or worked out successfully, and that's already it. So let me now build the workspace extensions again. Because like, since we changed our local workspace executor, we need to rebuild it, of course, because like we reference it from that dist folder. And now we should be able to actually invoke again the nxconf project. And so that should then run the build. Now let me also use skip nxcache to not basically use the cache of the previous version. All right. So if I go now to the actual dist folder, we should see the nxconf, we should see the readme HTML, and we see now our markdown file that has been compiled. So the executor worked properly. Now, obviously, as you can imagine, like one downside of this approach is that we need to have the executor already pre-compiled, right? So if we create a new workspace, that wouldn't happen, right? And so what you would have to do is you would have to first build it and then run it. Now, obviously, the possibility what you could do is like you could use the post install script, which you might just place here, and then basically just like add your compilation step of that executor. That would work, but you can also make a more like use a more elegant approach. And so what NX already has in one of the latest versions is such a target dependencies configuration NX.json. And for the build, that is already set up for us. And so what this means is nothing else than whenever a build is being executed, make sure that if it depends on projects that need also to be built, execute first the build of that project, so the build target of those dependencies, and then the actual target itself, right? So for our workspace JSON, that will mean for nxconf, whenever we execute this, it would figure out the dependencies to the actual builder, and then it builds the builder first, or make sure it has been built before, and then only builds the actual executor here. Now, there is no actual dependency, of course, because like there's just this only string here, so NX is not yet able to figure that out automatically. So what we can do again in NX.json is we can just leverage the implicit dependencies here. So as you can see here, there are already implicit dependencies defined, but we can just go ahead for our nxconf project and define workspace extensions, right? And so whenever we now execute our nx build, like yarn nx build nxconf, what we would get is it first executes the build of our local workspace executor, and then it actually executes the build of the library itself. And so this way, we would be sure to basically have both executed properly and the build result be placed in the output folder properly. All right, So what are the main use cases for a plugin in general? Now, obviously, in this case, we used, for instance, a local plugin to create such a custom workspace executor, which otherwise would be kind of weird and like not really comfortable in terms of the developer experience to create. But like the main thing is also like once you have such a plugin created, there's nothing actually in your way of actually also publishing it, right? So as you can see, we created that plugin via generator. We kind of implemented a couple executors in this case, but you could also add some more generators or migrations in there and then publish them to a local NPM registry or even share it with the community. And that's actually a good point in terms of the community work, because like you might not actually need to create your own, right? So there is already a vibrant community, which you can see on nx.dev/community, where there are like dozens of different plugins for NX, which you can use for different languages and different kind of use cases. And so chances are high that if you have some specific use case, you might already find something very similar. So you might even consider contributing to them. And apart from that, we have a lot of different channels. Like there is some community Slack going on where you can kind of reach out for help and discuss with other people. Obviously, there is our GitHub repository, which you can like just access and discuss things there, open up issues, or even like participate in some feature discussions there. Our Twitter and our YouTube channels as well, where we have office hours and you can interact with us. So the takeaway in general, which I would like to give you from this talk is like, don't be afraid to dive into executors and generators. Like they sound kind of weird and kind of away initially in the sense that they sound complex, might not be something like the kind of an overkill. But as you have seen, like the NX Devkit dramatically reduce the complexity. So there's no kind of observables involved. There's just plain async programming, and you can just like really easily follow through the steps, and even debugging is pretty easy. So it's kind of something you should definitely have a look at. Now, you might not always need ASTs, right? That's also something we learned today from this talk. But if you need, like there are some cool tools around that help you out. And also for the ASTs part, check out our NX repository again, because like we have dealt with a lot of complexity there already. So it might be something in there for you as well. And obviously, finally, the quality improvements can be like enormous, right? And also in terms of the speed and productivity, because like if someone creates a generator like for some repetitive tasks, like that allows people to very quickly, easily spin them up and just execute them. And you get like that speed improvement, like in terms of the productivity, but then also the conformity with whatever the generator sets up. Also, finally, shameless self-promotion plug, we have a free community course on Egghead, Scale React development with NX, which goes really into the depth of NX and in general, like how it works and the various concepts. So if you're quite new to NX, definitely check that out. It's on Egghead. It is about React, but it's really like mostly just using NX, so you could really easily also apply it to Angular or other frameworks as well. Finally, the source code is up here on this repository, so check it out. And otherwise, if you have questions, reach out to me, connect with me on Twitter, and thanks.